absolutely thrilled to have a challenge submitted by the one and only Kate Brown this week. So let's go through the solution for it. So we're looking at women's golfing. So we have some information here about the different championships each year and who won and what their score was, and information like that. We've also got a little bit more of a breakdown of that information, so which rounds they were in. So we're just going to bring all of that together by joining on the year. We lose 1946 because we don't have the breakdown of the rounds, and therefore it's not very useful to us, because we want to be able to, if you've seen the visualization that Kate did, we want to be able to look at each round in turn. So yeah, we want to get rid of that year anyway, so that's not an issue. So then we do a little bit of calculations. So we're looking at the par score. So we have the par score because we know what the total score was of each player, and we know how below or above par they were, and the E here means that they were equal to par, so we just would add on a 0. So the way that I wrote that calculation was just to say that we're doing the total minus, we're dealing with the fact that if the par is an E, then we have that as a 0, otherwise we turn that to par into a number so that we can minus it off. And the reason that we minus rather than plus is obviously to do with how if you're under par, then your score will be lower than what the par was, so we need to do the minus so that we add that par on. If that makes sense. I'm doing my best here with the golfing terminology. Clearly not my area of expertise, but trying not to butcher it at the same time. So now that we have the par score overall, we can work out the round par score, and we're just dividing that par score by 4 and using a ceiling function to round it up to the highest integer. So that's nice and simple too, and gives us our values there. Just removing some duplicate fields at this stage, but it's kind of one of those data sets where you kind of don't know what you're going to need, so you kind of keep keeping things in. That's definitely how I approach the problem, but don't worry, we remove all the unnecessary ones later. So now we're going to pivot our data so that we have a row per round. So for each year we would have 4 rows and a row for each round. And then comes the dreaded polygon step. Well, not so dreaded if we look at the Fleurlage twins blog all about that. So our first step is data densification, unioning our data to itself 4 times. So that feels immediately quite bizarre a thing to do, but you kind of see where they're going because you need 4 points for each of your squares. So that's what we're doing in this part of the challenge. So the way that I did that was that I added in a union step. So that created this step here, and then kept adding in clean steps to then drag that to add to the union step. So that's how I went about building that union. You could have built 4 clean steps and then unioned them one by one. You know, any way works, right? So now we come on to the polygon calcs, which are described in that blog. So I won't keep flicking back and forth. I'm sure you can have that open too if you need it. So what we're doing here, we're calculating our round to par, first of all, which isn't really a polygon calculation. I shouldn't have put it in this step, but nevertheless. So I'm going to keep zoomed in, I think, for this, so that I don't keep zooming in and out and making you all feel dizzy. So round to par is just the round score minus the round par score, which, yep, again, that feels quite self-explanatory when I explain it out loud. Now we want to number our points, and this is based on our table names that are created from our union step. So you can do a case statement, and else if, you can do anything you want, but how I chose to do that was I clicked on my table names and I went to the create calculator field and I created a rank. And I created it as a dense rank just so that I got the numbers 1 to 4. I didn't think it really mattered which ones were numbered which, so that's the way that I did it because I'm lazy and don't like writing out long calculations, and I like to make the most use of prep that I can. So then we're just getting rid of our table names. We don't need those going forwards. And this is where it starts to become a bit more polygon calc oriented. So first of all, we're sort of based on the rounds, we're assigning our squares colours. We're calling them A, B, and C here because naturally, when you're in Tableau Desktop anyway, you would have to assign those colours. Maybe I want to change my colour palette later. I don't want to be stuck with those choices, so A, B, C, and D works well enough, right? So then we're coming to our side length, which is just, in our case, the square root of the round score. So that's, again, pretty simple calculation, but now the X and the Y coordinate is where it gets a bit, whew, we've got to write that out quite methodically. So we're looking at each of our colours, and different colours mean that we have to do different things to different points, if that makes sense. So this is the calculation that we are looking at here. I would really suggest referring to Tom's solution for this post if you want to copy and paste these calcs. So make sure you check that out. But just based on the Fleur-Large twins blog, then this is how we are writing it in our case. And then the y coordinate is very similar. So we'll just go and show you that too, just briefly. Just based on the square colors, we're going to do different things to the points. So that's all worked nicely for us. And finally, there's just one more thing that we want to calculate, which is our over-under par round. So we're just saying, classifying things as to whether they have a negative or a positive, or if they're equal to the par for each round. So that wasn't too bad, was it? That wasn't too bad. We haven't blown our minds too much. We've got our calculations working, and that's great. Now we just need to do something a little bit more familiar, which is turning our years into decades. The way that I chose to do that was to say you have your 4-digit year. We're going to take the first 3 digits and stick a 0 on the end. That's basically all this calculation here is doing. You're wrapping it in an integer because to use the left function we had to turn the year into a string. And we're taking those first 3 digits, so 1990, and then we're adding a 0 to it, so it stays at 1990. Nice and simple. And then we're using a similar logic again for the row number, where we're using our ranking. And that is just ranking based on the decades and making it a dense rank again, so that we get those row numbers. And then for the column calculation, it's quite a similar logic to how we did our decade. Everything's kind of fitting together nicely, right? All the skills kind of keep coming into the same thing. So for this instance, we're taking the final digit of our year. So say it's 2001, that would be a 1, and we're adding 1 to that. So that gives us our column. So that will help with building that viz. Then we're just removing some fields and we're preparing that for output. So that's one of our outputs done. Now we're looking at those min-max values. So we've had our data all densified. Let's just go back to aggregating it to be sort of 1 row per year and per round. So we are taking the decade, we're taking the year, and we're saying what is the average round score and what is the average total, because we're doing the averaging because we did the densification before. And now we're just duplicating those fields so that in our next aggregate we can have the min and the max for both the total score and for the round score. And that's it. That's the challenge. Thanks so much for watching. Thank you very much, Kate, for submitting the challenge, and I hope you enjoyed.